All right, great. Let's go ahead. Welcome everybody to this Climate Cafe Green Blue. I'm Sydney Stucks. I'm from the municipality of Nijmegen, and I'm doing this Climate Cafe with Floris Bogart for over 5 years now. And I think how many years do we already do it, Shanae? About three already, or two? Oh, okay, well, that's okay. But we also for 2 years with Shanae. And we're always talking about green blue topics like bioswales, floating cities, participation projects in green villages, and such. And today we also have another reoccurring topic, and that is flood protection. It's a little bit broader, I think, than only flood protection, but that's because of the background of our lovely speaker today, Matthias Weber. Thank you for coming. Um, yeah, is it okay if I just give the floor to you right now?
Yeah, of course.
Do you have a presentation, Ray?
Yeah, I will
Alright,
try
let's
to.
try to share it. Great. So do you want us to keep question to the end, or can we question anytime?
As for me, it's fine if you do it anytime. Just if there are questions, just ask.
All right. Then the floor is yours, as you say.
Okay. Yeah, I also from my side, I'm Matthias. I studied architecture and green building design for my master's studies, and yeah, now I'm working as an architect and also energy consultant in Berlin, Germany. And I'm also volunteering at the Blue Revolution Foundation, which is involved also in the Floating Future research project. So today I will talk about a case study of the island of Wangerooge, which is in the north of Germany. I did this case study for my master's thesis 3 years ago. So yeah, and from that case study on, I will lead to some conclusions regarding flood protection using floating villages and other measures. So yeah, as I said, I will have a little introduction on the top case study on the island of Wangerooge, because I assume not everybody knows it. Yeah, then we'll present the different options that are available or that are thought of for this island, do a comparison of all these measures. Yeah, then lead to some recommendations regarding this flood protection measures, and yeah, have a little outlook at the end. So yeah, as for introduction, I think most of the people here are aware of that yeah, many people will be affected by flooding in the next century, or also in the next years also. There are by 2100, there are like 630 million people in low-lying areas that are endangered by floodings. Also, there's like 894,000 square kilometers of land that is endangered to annual floods. So every year occurring floods in the year 2100, and there will be storm surges that are as high as 9 meters above the average sea level on a 100-year flood in 2050. So that's not that long from 2026. So from that on, let's have a look on the case study and also on Wangerooge as an island. As you can see here on the map, Wangerooge is the most east of the East Frisian Islands on the North Sea coast of Germany. You can see Groningen, that's nearby. Yeah, and I also marked the stream direction that is present there, which is also a big part of the problem, specifically on these islands, because there's a very intense stream towards the east, because the ocean waters and storms that come from there, yeah, pushes the water into this little, or into this quite big bay that is surrounded by Norway, Denmark, Germany, and the Netherlands. And so the more you go to the east in this in the North Sea, the higher the flood risk is, and the higher the floods will rise, or at least are projected to rise. Yeah, focusing on the island itself, you can see it has one main village, which also lies on a little dune, so it's a little bit higher than the rest of the island. And it also has a little second village, which mainly consists of hotels, youth hostels, and other tourist accommodations. But yeah, it's located at a very far west end of the island, and from there all the water comes. And due to this stream of water, there's also the problem that the island is slowly moving towards the east. So the sand and other materials are eroded and are flooded to the east of the island. And so because that's also the reason that the island has this section here at the east end. So this is where all the sand goes that is flooded away from the west end of the island. And that is what also specifically this village makes very vulnerable to flooding, because if you build some static flood protection methods there, they are not very stable for a long time because the ground underneath is flooded away over time. So it goes that far that the island is like moving like 1 kilometer per century, so that's quite a lot. This western village was like a few hundred years ago the main village, which was sitting in the middle of the island. So just to see how rapid this moving of the island is. Of course, there are several risks that that follow from these the specific conditions. We have like a potential damage of 53 million euro. That also not only includes destroyed buildings and rebuilding the buildings, but also includes like production production interruption due to flood dangers and damages. The island, as you can see, marked in the pale blue area, is risked to be nearly entirely flooded if the dikes and dunes are not raised in the near future. Currently, they are like 6 to 7 meters above the average sea level, but also the 9-meter high floods that I mentioned in the former slide also apply to Wangerooge because of its location where all the water is pushed to and is stopped by Denmark and German coast. So there's a lot of flood endangered area at the moment. So that's also a very big challenge. Yeah, and there's also the loss that I mentioned from the production and other GDP loss. Yeah, what the community of Wangerooge and also the state of Niedersachsen is currently planning to prevent this is like raising the dikes and add protective layers, especially in the west end of the island, to prevent the island from moving. This is what works fairly good. So the island is not that much moving like it was 100 years ago. So they managed to not completely stop it, but really slow down the moving of the island. What will not work that good is the rising of the dikes, because there's only projected to rise them by 1 meter, which will likely be not enough if you look at the projected flood height in the future. So at least at a 100-year flood, the island will continue to be flooded nearly as the whole, nearly on its whole area. So yeah, that isn't the ideal solution for all the problems we have there. And from that on, I just looked at 2 other options that are not discussed by the government at the moment, but are also at least in my opinion, a very suitable options. And I will be focusing mainly on this Eastern Village because there are so much kilometers of dike and dunes needed to protect these few houses, whereas in the main village it is in its main part high enough to withstand the flooding that is projected, and also is more compact in a little way. It has more housings in a it has simply more housing density. So yeah, first option I looked at was a flat barrier, which is you can say a mixture of building and a dike. So you can the plan is to just abandon the Western Village from over the longer time and move all those usages that were located there to this multifunctional barrier. You can imagine it like a long building, which is shaped like a dike at the outside to just break waters and let waves roll out. Then after you did this, you don't need necessarily to maintain all those dikes that are here at the sole end at the island. So that saves a lot of resources and also costs, of course. Of course, you have to build this barrier once, but in this scenario, these barrier will be at 9 meters at least, 9 meters high. And also the dikes, the remaining dike line, which is about the half of the now existing dike line, can be maybe rise to 9 meters to prevent also the main village from flooding. Yeah, here you can see it a little better. It's mainly like a line of housing. Of course, it is a very, very big scale compared to the buildings that are existing at the moment on the island, which you can see here on the right. Because of that, I moved it a little bit away from the main village to just make this contrast not that strong. And as you can see here is also little woods and little forests at these sections, so that the building will be not free inside from the main village. That's what the thoughts behind this are. And the idea is simply just to reduce the dike lines and dunes to be maintained or to be extended to a level that will prove will prove as a safe way to handle the floods that are projected at the future times. Second option which came into mind was a little more flexible option, which also considers the moving of the island, which is, as I said, slowed down at the moment, but not entirely stopped. This idea relies on replacing the Western Village with a floating village, or to make it floating. In this case, you also don't need the dikes for flood protection. It is okay if there come a flood, the foundation or the anchors of the floating buildings are in this scenario meant to withstand all the flooding that are come, and the dikes that were overflooded at a flood are just meant to serve as breakwaters or measures to reduce the waves that could affect the floating village in this scenario. Also, again, the main village remains untouched, and the dikes around it will be a little bit raised. That one thought more about the resources was also that the bay, which is projected to develop here to house the floating village during not flooding times. The earth and material that is removed here could also maybe be used for the dikes to make them higher. Yes, one other advance of these floating village is, of course, it's not fixed to a position. So if the island continues moving and this part of the island will be, will be away maybe in 100 years or whenever it will be, and you can remove these houses from here and can maybe attach them to the main village. So yeah, you can just react on this moving island and to the floods. So it has like two ways of protecting the people living there. And that's how it could look. Yeah, of course, there's also other formations thinkable, but in this scenario, it's just built up the way that here are more bigger modules on the shoreline, which house more open or public usages, such as little shops or maybe also assembly rooms for the youth hostels or hotels that are located there, whereas the smaller modules here, yeah, mostly are for housing functions or for the bedrooms of the hostels or hotels. Yeah, another plan how it could look like if this floating village moves to the east over the time. Yeah, there's thinkable just to fit it into the floor plan or into the situation of the village. Just connect to the streets on the land. That were So from this three options, I made a comparison in the ecological, economic, and spatial or urban planning point of view, and also did a little outlook that is wider than just this case. How the results will change if there are more or less houses to be protected in these Western Village, to see the point where maybe dikes are useful or at which density it isn't useful anymore. So for that, for the ecological analysis, I did a life cycle assessment, including material sourcing and crafting, transport and construction on the site. Of course, the maintenance and repair and also replacement did, of course, over the usage time. And of course, at the end of the cycle, the demolition and the transport. Yes, I excluded the recycling because I don't want it to rely on recycling methods that are available today when the building maybe will be recycled in just 100 years. So we don't know which methods there will be available in the future. So yeah, I left that out for today. Assumptions that were made is the dike length stays the same, of course, because the island is not bigger, it cannot grow. And I've also made the assumption that according to the current plan, where the dikes are only raised by 1 meter, that the village in the west will be destroyed once in the time. I looked until 2100, so I assumed that there will be one once in 100 years flood. So that will be like 9 meters high. Yes, as for the materials that are also important for this life cycle assessment, I planned the floating village with concrete bases and timber house frame. The barrier is, of course, made of farrier materials to prevent hovering up when the flood comes. It's mostly made of brick and concrete in the walls and, of course, concrete ceiling and roofing. Yes, the rebuilding of the village when it is overflooded, and the assumption is that it will be rebuilt the same way. It is also today made mostly out of massive brick walls and concrete ceilings and traditional wood constructed and roofs. So the formula I used for this comparison in an ecological way is contains the global warming potential of the flood protection, which means the dikes and the dunes, or the extension of these. It stays the same for each scenario. Of course, the scenarios differ from their global warming potential of the flood protection. But it stays the same because the dike will not be longer in the future. Added to that is the global warming potential of the buildings, which of course vary in my comparison, because I wanted to see how much buildings or let's say how the findings change if there are more buildings or less buildings inside these to be protected area. Of course, that's why I added the gross floor area there. And finally, the division is made again through this gross floor area of the buildings. So I'm hoping to find or I hoped to find an answer to which size of settlement it is usable to make the village afloat or build this multifunctional barrier, and when will be the point where dikes are more economic and ecologic for this scenario. Yes, that are the results so far. You can see here at this line, this is the amount of housing space that is in the at the western village of Wangerooge. So you can see, as for Wangerooge, the global warming potential per square meter gross floor area is the lowest if you make the buildings float and construct a floating village here. You can see the barrier is a little bit higher. Of course, there are difficulties to enlarge the multifunctional barrier to fit in more square meters. It's not that easy. I will come to that point later. And you can also see the current plan is way much higher at the Wangerooge case. That's because there is so much material needed that needs to be transported. Everything comes with ships that are mostly driven by fossil energy at the moment. And it's simply just a much higher use of materials that is needed. So next comparison aspect is the economic view of point. Sorry, I always mix up ecologic and economic. So the economic point of view, it's represented here as of the life cycle costs of these three scenarios. So in the whole life cycle, I put together the construction costs, the demolition costs, if there's a demolition to be made, which is the case for the alternative scenarios. There is the demolition of the existing village. The usage costs, of course, maintenance costs, and also replacement costs. Excluded is the cost of the existing buildings and dikes, because they are already there, and there are the situation that we go from as of today. So assumptions are nearly the same as in the previous comparison, in the ecologic comparison. The parameters I used are the costs are from the time I made my master's thesis. It's some time ago, but I think if you apply some factors or inflation to it, then you can also get more recent costs out of that. I applied a factor of 165% of the average building costs in Germany because the island is has much higher building prices than on the land, because you have to ship everything with ships there, and also workforce is not that much available as on the land, so you have maybe to ship people also there, and and house them for the time of construction maybe. That's the one thing I made, and also I applied the maintenance costs of the dikes, or calculated them by calculating like 1.5 to 2% of the building costs per year. That was some sort of a very rough method I found on some literature to that. And I applied the long-term inflation, but not the current inflation. It's I think much higher, but looking for over the past years on a longer term, like 20, 30 years, it was statistically about 2%, and a discount rate of 1.8% in a 10-year average perspective. So the formula I used for this comparison is similar to the ones or the one I used in the ecologic comparison. You can see here there's also this fixed amount of existing dikes and dunes that are, of course, vary above or vary through the scenarios, but stay the same no matter how much buildings you build inside them or not. For the first formula, just to be clear of that, is used for the current plan. So we have the costs of the existing buildings, which need to be rebuilt in this scenario. So that's the additional cost that comes specifically in this scenario, and also the costs, of course, of the added or subtracted buildings compared to this scenario. Of course, it's all again divided through the gross floor area. So, and for the other scenarios, which means the multifunctional barrier and also the floating village, there's of course the same formula as in the ecologic comparison, which also includes the fixed flood protection costs of the varying building costs divided through the gross floor area. So, and if we look at the costs, you can see that at the size of the western village of the island of Wangerooge, just from the economic point of view, the multifunctional barrier is the cheapest when it comes to life cycle costs per square meter, which, as the current plan again is the most unfortunate scenario. In this case, you can see it produces much higher costs. But you can also see there that here there's some certain point at around 60,000 square meters where the changes and the floating village will be the most costly scenario, and the dikes will go beneath that. Can be explained, I think, with the factor that for every floating building you have to build the same, have the same, the same, or the same measures to make it float and build it. Whereas at the current plan, you have to rebuild, you have to enlarge the dikes and extend them. But if there's a building, you just build it normally and don't have to touch the dikes again, no matter how much house there inside. So after some size of the building inside, the dikes are maybe a considerable option. So comparing the urban and social aspects, I just extracted a few ones because I think it's too long to look at all today. Advantages of the dike rising. So that means the current plan of the government is they have a familiar appearance. The inhabitants of the island are used to them, and they are integrated into the life of the people. There are like cycling pathways on top of them, and everything similar. There are local experts available because there's many centuries of dike building in this area. And there's no need to move for the inhabitants initially when constructing it, because the buildings remain untouched until they are flooded. After then, of course, they have to move. That's also one of the disadvantages, that the part of the main and the whole western village will be destroyed at a projected 100-year flood. And of course, it is at the current size of the village is expensive and difficult to construct, because there's so much material needed, and at least at the region of Eastern Frisia, there's not enough sand to construct all these dikes. So you have to carry it on from very wide areas, because I think the nearby regions in Denmark and the Netherlands also need their sand for dikes. So yeah, it will be very difficult to get the material there. Protective layers that are built today, made of concrete or other materials, are not very welcoming spaces for people to just spend time there. Which certainly dikes are more welcoming, which just have grass on them. Concerning the floating village, there are advantages is when you look at the multifunctional barrier in comparison, there's not that much, not that one big barrier between two parts of the island. It's the original appearance of the island will be always there. No several damages during the floods. Of course, maybe through some waves, there will be minor defects on the floating buildings as well, but not comparable to that will happen to buildings that are 9 meters under the water level suddenly. One more advantage is also the flexibility of buildings and the users in terms of place and expansion. So you can more easily expand it. You can move it to the east if the island continues to move, and you can also and it's also more flexible for the users, so they can move away with their house or move there with their house. Disadvantages is, of course, inhabitants need to move from their old home to a new home. And the old Western Light Tower that is there, it's listed as a monument at the time, will be lost in this scenario because it's not protected anymore by dikes. Multifunctional barrier has an advantage compared to the floating village that has a more similar experience to the dikes, which are the ones that are people used to over the last centuries. Inhabitants only need to move once, or maybe this is also part of a disadvantage because it's not flexible, so they can only move once. So if the island is wandering, of course, the multifunctional barrier is located more to the east than the current village, but after some centuries, maybe it will also be just flooded away by the sand moving away underneath. It separates the island into two pieces. That's what I said already. And it has a more urban character than it's maybe appropriate, considering there's quite small buildings, which are mostly one-family houses, in comparison. So it seems, as a conclusion from that for coastal landscapes, which I would count these islands also on, there are maybe if you want to protect larger settlements, it's better to have dikes. And if you want to protect smaller villages, such as the Western Village on Wangerooge, it's maybe better to make them float. In river deltas, which also have the same problem, as Wangerooge, with very moving undergrounds and not very static environments. It can be the same. Only difference is dikes are not very good there because you often have brackish water there, and which results from the water from the rivers and the sea that are mixed up there, and that will not happen anymore if you see on the IJsselmeer, for example. So that will have a dramatic ecological impact. Yeah, and for coastal cities, of course, there are very big, very big settlements. So floating buildings are maybe not that applicable there, except from the scenario if you want to expand them outside from the dike lines. So there's also the question if there's a minor extension from the city outside the dike lines, it maybe it's better to make it float and then surrounded by dikes, which will consume tons of materials. So yeah, that's also the last slide for today. Outlook that is, or further research that needs to be done is, of course, this is an analysis based on a specific case study. So there are other regions in the world where maybe the availability of some materials is different. So, or maybe the transport is different. And there's a different environment, maybe with different priorities. Of course, as I said, the deeper analysis of transport routes and production conditions is also a thing that needs to be considered. Also, you have to consider decarbonization processes maybe in the production and also in the energy supply, which changes the footprint maybe during the usage of the buildings. Separate investigation needs to be done on costs or on the problem which costs are come to the municipal side, or which costs also come to the users of the building. Maybe also development of potential funding programs for people in these regions, such as other funding programs for other problems that our people owning buildings are confronted with. So, and I think the most unresearched area of these is at the moment maybe the deeper analysis of the global warming potential or the carbon footprint. So there are a lot of generalized assumptions when it comes to calculations most of the time. So I think there's a lot of research needed to be done because every situation has different parameters on that. So yeah, that's it for today. That's sources, and thank you for the attention. And of course, if there are any questions.
Yes, thank you. That was very interesting. I just had a question about you said recycling of materials, and you didn't consider that in your study, which I fully get, because what will happen in 100 years, things could be completely different.
Yeah.
But the materials that you suggest using for one or the different options, that is still going to be sustainable type of materials that has recycling potential for future, right?
Yeah.
So there is some level of consideration in terms of
yes, it is. Yeah.
Future. Okay. Yeah. And then maybe I can just read Christian's. I see he had to leave, but maybe I can just read his question before Sydney. I'm sure he also has questions. So I'm conducting an artistic research to a similar place in Zealand, and since I'm interested in future economies that keep people in the environment, do you have any ideas about the kind of income that the Wangerooge could have in the future? Any ideas about the kind of income? So from a social perspective.
Yeah. You mean for the alternative concepts, or
He didn't
Oh.
say, just basically that he's working on a similar research for a similar place in Zealand. So he's looking at the future economies that keep people
Yeah.
in the environment.
Okay, yeah. Okay. I think which will be an advantage on this when it comes to floating buildings is also you can maybe inhabit regions that are not that inhabitable at the moment, maybe. That would be one point I see out of this. Yeah, I think that's yeah, also and also a factor of if you look at the case of Wangerooge is also the that it could be a touristic factor, of course, because it will be the only of at least of the East Frisian islands that have floating buildings, and most of them are also hotel use. So that could be also a thing that the island could profit from, I think.
Yeah, that makes sense. More recreational and touristic kind of aspects. Yeah. I think that's all the questions I had.
Great. Yeah, it's a bit, how do you say it? Next to some of the questions I have, because of course the moving will take money, and I'm just filling in the gaps here. But I think maybe Christian is wondering like how does these people going to get can get pay their new homes. However, if you have shown is that these alternative scenarios can reduce costs or at least reduce impacts, that for sure. And an example here in Nijmegen is a room for the river where a lot of people had to move. And we just did some buyouts because people were like, well, I can't afford a new house and I don't want to move. So that might actually be a stimulant to get it. But of course, in the long run, especially after 100 years, people are just in the housing market. And then I was wondering if you have thought about the because I like the multifunctional barrier. It's really a cool concept, but also because it's embedded in basically in a dike like construction, like how this maintenance will look like, because it's a dike in a building.
Yeah, of course, that will, I think, a little bit challenging.
Yeah,
of course.
yeah.
I just thought about also what will happen if the dike fails or is letting some water maybe through. So I also did a little bit of zoning of this building, so that the higher floors are more for constant living and constant people usage, whereas the lower levels are more like shops or things where people are not all the time, and that could be evacuated easily. Also thought about rescue ways, so ways to rescue people if there's signs that it will fail. And of course it will be difficult from viewpoint of construction, because the dike and the building may have other pressure on the ground, for example. Also will be a challenge to prevent the water from underflowing the barrier, I think. Maybe you can handle it with some sort of steel in the ground. And also prevent, of course, the building from getting pushed up by the water. And
You need some weight.
Yeah.
That's actually quite cool. And we have something similar probably also in Germany, but like we have some buildings on that are built a bit higher, but we have the incoming flow from the rivers from the underground at least, and there we also have these steel often these steel constructions that are maintained by water boards, yes. But right next to that is the wall and the parking ground. And the parking grounds, similar, like you said, is of course a function that's, you don't want to have your car flooded, but it's a lot less worse than your home is flooded.
Yeah.
And it actually kind of works both ways. I noticed, because the regulations for safety in the building structure is much higher, and they actually say that, well, leakages and stuff are probably noticed sooner
Yeah, maybe.
than when you just have your dike with maybe a steel in it or something.
Yeah.
So this is really, really pretty interesting. And of course, a lot of discussion, like, who's going to pay for that? And but that's always the case. But it's actually quite cool that that there are also a lot of opportunities there. And of course, if you live there, you have a really nice view. But that's just my opinion.
Yeah, of course. Yeah. I
Yeah,
was
and that's
people that said I could never live there. I would be too much feared if anything happens to the barrier. But yeah, I think
yeah,
it's
yeah.
some say so, some say so.
Yeah, and I also had a question about because you quite of went over that quite quickly over the tube barrier.
Yeah.
So that was so that's a floating barrier, right? And that's why it's that one,
Yeah. That's
and it's placed on a really different part than the multifunctional barrier, right? That
yeah.
multifunctional barrier is much closer to the town,
Yeah.
and this one's much further away. And I was actually wondering then, why wouldn't be a multifunctional barrier at this spot be useful?
Yeah, at this case, I decided to move the barrier to another point because this is the area where woods and forests are present,
Okay.
and it was a more of a spatial or architectural background of this decision, because I just wanted to hide it a little bit so the people in the main village don't look at a more several hundred meter long
Yeah. So
building.
this the more natural landscape is kept this way, and then the
Uh,
other one, it's already, like you said, more urban than appropriate.
Yeah.
So then it's lost
Yeah.
already. Yeah. Okay.
Yeah.
Okay. No, that's that was
And
one.
for the tube area, I just simply looked to the place where is the shortest distance between the dike lines. So
Yeah.
just different considerations.
Okay. Cool. Really interesting.
Yeah, Matthias, the 9 meter water level
Yeah.
rise, is that on a 2100 scenario?
Yeah. That would be
Okay.
on a by 2,400. Yeah.
And is that kind of worst case scenario?
Yeah, it's the worst case. Yeah.
Okay.
Yeah. And this is okay. Um. Okay. Cool. Yeah. Yeah. Just have an. I really like your result about the bigger versus small area, that there is a trade-off.
Yeah.
It's really interesting to find. It's also, floating is probably, if we're going to start it, it's probably going to be small scale anyway.
Yeah.
And that's actually a really good sign that we know, like, okay, then it's feasible, it's economically and ecologically positive compared to the other measures. But still,
Yeah.
dikes will be needed. Yeah.
Yeah, of course. Yeah, that's also, to be honest, a topic where maybe I'm hoping for to do a PhD maybe in the future on or something like that. So
Yeah, then
because
you can
I
get to answer all the other questions you just
Yeah.
wrote up.
that's
Yeah.
because there's so many interesting questions that are that I'm thinking all the time about, but at the moment I don't have the time for
Yeah.
to do research
And I
on.
think
So
what I really like is that you have these in one bit quite different scenarios to compare. It makes it a bit
yeah.
harder, but it makes it a bit more real, because if somebody goes into the topic just on floating and all the trade-offs, and maybe have like different sizes and models and stuff, it's also still really interesting. But these are really the choices that are going to be made for this kind of areas. It's about a lot of money, and it's going to be like, do we sacrifice this part of the land, yes or no, and why,
Yeah.
or not? and we're just going to pay a lot of money and do a lot of effort.
Yeah.
Cool.
Would you maybe in future also consider doing like cost benefit analysis to get more of a feel for comparison, not just on ecological or just economic or just social kind of benefits, but get the whole picture?
Yeah, of course. Yeah, I think that's also things that need to be considered and that I'm also very interested in. Yeah. I have to say it also kind of frustrated me back then that I only had 5 months for that, so I had to focus on yeah.
Yeah.
Not that
Well,
much
you've got a lot of
topics.
work done in 5 months, so that's impressive.
Yeah, really nice. So
Yeah, but
there was one thing I was wondering, a bit of a different question, but is the island also growing on another side?
Yeah, you can say the material is transported from here to there.
Yeah.
But there's also a change in that because of the climate change. There's also how to say it, the stream is more strong, and so the transported material, not all of it lays down here anymore. So some material is also flooded away to Denmark or Germany on the coast. So that's what I found out when I spoke to the people that are responsible at the moment. They said yeah, like 20, 30 years ago, it was no problem. They just needed to carry the sand from here to there to repair their dikes, but now it doesn't work that much. And they said literally to me, our biggest problem is not that we don't have enough money for flood protection. We don't have enough material for flood protection.
Yeah. I noticed that during your talk. That's the biggest issue. Yeah. Okay. Yeah. Well, interesting. So you get less land back, and it's going to take more effort to get it back. So, do you have a preference for these, especially between I'm especially interested between the floating and the barrier.
I think in the case of Wangerooge, I would prefer the floating village. As I said, it's also flexible enough to handle the moving island, and yeah, so you don't necessarily need to carry all the sand back. So you can just let the island move as it does, and have those floating buildings that are moving with it.
Yeah, your biggest kind of negative that you found there was the loss of fresh water kind of ecology, right?
Yeah, that can be a big issue sometimes, but if you're ready to let it go, then you will create new cultural area. All right. This were my questions. Thank you. Really interesting. I hope we're going to see you back in a few years, and when you're doing your PhD on this.
Yeah, I hope so too. Yeah.
Yeah. All right. So no further questions, Shanae?
Nope. Very interesting. Thank you, Matthias.
Yeah, thank you, Matthias. I regret to announce that we don't have a topic yet for next week. So that's really sad. However, we do have a lot of great topics for the weeks after that. I think we had a topic on, I just deleted something. Not too bad. I had like a whole list ready and now it's just gone. But no problems. I will have it here. So next week nothing. The week after that we have in Dutch we have an update about the street water infiltration project we do here in the Netherlands, and we're actually doing with Nijmegen, but also with Amsterdam, Arnhem, and it's about how we can make infiltration more environmental friendly, but still feasible to protect cities from flooding during extreme rainfall events. And after that, we're going to have somebody from Deltaras who's going to talk about building and I also have problems with this English word, but I would just call it the lowering of the ground level because of the lowering of the ground water levels. So a little bit related to this problem here. And what you can do with infiltration. Does it really work? Does it really help? What is what are all the problems in the background? And can you build on weak ground? So that's actually a little bit of a bridge between the topics, because then you I already know that some of the ideas are some semi-floating buildings that are able to be built on weak grounds, but we're going to see all other measures that they can take. And after that, we're going to an eco village, and it's from a village in Zealand. So I think it's going to be in Dutch again. Kees Mutter is going to tell us about his motivation to live there and how it is to live in an eco village. Then we don't have a topic for 1 week, and after that we're going to talk about digital twins for water management from the province of Overijssel. They're doing everything in 3D these days, which is really cool in itself, but also really useful. So probably don't see you next week, but after that, hope to see everybody that's listening. And thank you again, Matthias. It was really interesting.
Thank you for the invitation.
Thank you,
Bye-bye.
Matthias. Okay, bye. Bye.
So a bit long, but really